Ashley here from Smart Edition Academy. We're going to be talking today about some common math mistakes that I want to help you avoid as you take your entrance exam. So if that is something that sounds interesting to you, then I think this is going to be a really fun session. I just want to talk a lot about the different types of math you're going to see and mistakes to avoid. So it'll be just in the back of your mind that, once someone else has made those mistakes, hopefully now you won't have to. So questions we're going to answer together today. What kind of math will I see on my entrance exams? We're going to talk about the type of math you can expect. And then what are some common mistakes to look out for? So within each of those topics, what are some common mistakes that come up so we can avoid them? And then, of course, we're going to talk about what the problems will look like. So my suggestion for today would be to have a piece of paper handy, have your four-function calculator handy, have something to write with. So as we are going through some examples, you are able to practice along with me. Feel free to pause and listen and take it all in, but also participate by doing the problems on your own. Okay, so we are going to get started. Again, piece of paper, something to write with, four-function calculator. That would be awesome if you could have that handy. So let's jump into it. So we're going to talk about operations with fractions and decimals. What I mean by that is we are going to just remind ourselves of how to add, subtract, multiply, and divide and see, what are some things that we could get tripped up on with that and how to avoid them. This, of course, is including word problems. Okay, a big part of your test is going to be understanding and solving word problems. So we're going to look at some word problems there today. We'll talk about some conversion problems, being able to convert within the metric system, as well as converting back and forth between other units such as like inches and feet, or maybe you have to go from kilometers to miles. So we're going to talk about some of those things together today. We will talk about ratios and proportions, percentages, how all of those relate. We'll talk about order of operations, which essentially is just the correct mathematical order in which we solve math problems. You may have heard PEMDAS before. This is a fun mnemonic that allows us to remember the proper order of operations. PEMDAS, please excuse my dear Aunt Sally, is maybe how you've heard that before. We're going to do solving equations with one variable, basically trying to get x by itself and find the value, as well as solving some exponents and geometry. So these are things you can expect to find on your exam. It's not an exclusive list. There are other things that may come up. Definitely find all of those in your Smart Edition course. These are things we're going to focus on today. Before we jump into our first practice question, let me remind you that we've made it easy to study and prepare for your upcoming TEAS test. Get everything you need to study in one place with the TEAS online course. Study A and P, chemistry, biology, scientific reasoning, math, reading, and English with practice tests, flashcards, videos, interactive lessons, and a mobile app. Now let's get into this first practice question. So common mistakes that come up when we're talking about fractions, okay? One common mistake that I see come up a lot with students is they forget that they need a common denominator to add and subtract. So as we go through each of these topics, I'm going to point out these common mistakes and then remind you of the proper way to do it. So something to keep in mind is whenever you're adding and subtracting fractions, you need a common denominator. So I need to add like units. I can't just add 1/3 plus 1/2 without knowing how they relate to one another. So I might need to get a common denominator of, for example, 6 and write them in terms of equivalent fractions. So we will talk about that in a bit. When we're talking about decimals, you have to line up the decimals when adding and subtracting. So essentially the decimal point needs to be lined up. And this is all about place value. So we're going to talk about place value a bit today and just why it's so important. But we're also going to use our calculator to help us so we can avoid this mistake altogether. Because again, we can use a four-function calculator. We can add and subtract and also multiply and divide decimals all within our calculator, okay? But I do want to just talk about place value a bit so you understand kind of what that decimal is doing there and why it's so important to line it up. when we are talking about ratios and proportions, the main thing that we really need to know is that our data is in the right spot. So a ratio is essentially just comparing two things. So for example, if I had, 2 dogs and 3 cats, the ratio of dogs to cats would be 2 to 3. Okay. If I switch that and wrote 3 to 2, that would be a completely different ratio. So we have to make sure things are put in the right order. So order is really important when we're talking about ratios, and proportions are basically just setting two ratios equal to each other to solve for like a missing value. And in that case, order and where you put your data is still very, very important. Okay, order of operations. I mentioned PEMDAS before. It's important to simplify expressions in the right order. If we don't do things in the right order, then we're not going to get the right answer. It's not going to be mathematically correct. The main mistake I see people make when they are doing order of operations is assuming that we go parentheses, exponents, multiplication, division, addition, subtraction in exactly that order. I like to actually write it like this because this reminds me that, yes, I have to do parentheses first. And then I have to do exponents. But when I get to multiplication and division, I am working from left to right. So multiplication doesn't always come first. Sometimes division will come first, but you need to work from left to right. And that also applies for addition and subtraction. So addition and subtraction, if subtraction comes first, once you get to that step, you're going to do that first. Okay, and then once you get done, then you've obviously done it all. But we're going to talk about a few of those mistakes there. Exponents, we're going to talk about how to simplify exponents and some exponent rules. And the main thing I want you to be careful of with exponents is negatives. So whether that's a negative in the exponent or a negative in the base, we have to be careful. I want to talk about some things to look out for with that. And then last but not least, we will chat about some geometry. You must memorize your formulas and know how to plug into them. Okay, we need to know that in order to be successful on this exam. So we'll just talk about the formulas you need and just some tips and tricks for how to plug in appropriately. Okay, so that's a little bit of an overview of where we're going. So let's jump into it. Okay, fractions. So let's talk about adding and subtracting fractions. Okay, remember I mentioned before, when we add and subtract fractions, we need a common denominator. Okay, so this first example, 2/5 plus 1/5, okay, notice how it already has a common denominator. So this is great because I actually can just add these without doing anything else. I don't have to get a common denominator as given to me. So visually what this looks like, okay, is 2/5. Okay, so 2/5 would be like if I had a candy bar cut in 5 pieces and I had 2 of them. Plus, let's say we had another candy bar cut in 5 pieces and I'm going to take one more piece of them. Well, notice how each candy bar is cut in fifths. Okay, so now instead of 2/5 plus 1/5, I can combine this to be 3/5. So once we have a common denominator, all we have to do is add the top and you keep the denominator the same. Okay, so hopefully that visual makes sense for why you add the top and keep the denominator. Excuse me. So let's look at one where we don't have a common denominator. 3/9 plus 2/3. Okay, so 3/9 plus 2/3, I need a common denominator. So essentially to find a common denominator, I want to think about the LCM or the least common multiple. So the least common multiple of 9 and 3, 9 is actually a multiple of 3. So we can rewrite both of these as equivalent fractions over 9. So 3/9 would stay the same. And then 2/3, well, I did 3 times 3 to get 9. So 2 times 3 on the top would be 6. And now that I have like denominators, if the visual helps you, you can think about the visual I used in the first example. And when you add them together, you add the top, keep the bottom, you get 9 over 9, which is the same thing as 1. So being able to simplify your fraction at the end to get 1. Okay, let's try one more. Feel free if you feel like you've got the hang of this. Let me know what you think would be a good common denominator for 7 and 5. What would be the least common multiple of 7 and 5? So feel free to drop it in the chat if you think you know. a little shortcut or a quick way to think about it, and really works for any set of denominators you need to use, is that you could always just multiply the denominators to get the common denominator, 35. It won't always be the least common multiple, but it'll always be one that works, and then you might just have to simplify later. So if we multiply 7 times 5, we get 35. Now we just need to find our equivalent fraction. So 7 times 5 was 35. So let's do 2 times 5 to get 10. That's the equivalent fraction. 5 times 7 is 35. 1 times 7 is 7. So we have 10 35ths plus 7 35ths. Now I have the same denominator. I can just add the top and keep the bottom. And in this example, there's nothing to simplify, so we are all done. Okay, so adding and subtracting are the same process. Get a common denominator and then do the operation it tells you. So in this one, 6/5 minus 3/4, what would be the common denominator? Well, 5 times 4 is 20, so we can choose 20. Make sure that you don't rush and you're noticing the sign. We are subtracting this time. So get an equivalent fraction and then subtract. 5 times 4 is 20. So on the top, 6 times 4 is 24. 4 times 5 is 20. On the top, 3 times 5 would be 15. So from here, I can just subtract 24 minus 15, which is 9. Keep the denominator of 20. And I can't simplify, so I'm all done. Okay, so one more example here. What happens when we have a mixed number thrown in there? Okay, so this would be the same if we were adding or subtracting, it wouldn't matter. My suggestion would be to turn the mixed number into an improper fraction, so then we can just follow the process. So, quick review of improper fractions. We take the denominator, multiply it by the whole number. 3 times 3 is 9, and then we add the top. That would be 11 over 3. Minus 5 times 1 is 5. Plus 3 would be 8, so this would be 8 over 5. So now I have two fractions that I just need to get a common denominator, and then I can solve. So 3 times 5 is 15. 15 is our least common multiple, so that's a great one to choose. 11 times 5 would give me 55, so that's our equivalent fraction. 8 times 3 would give me 24, so that's my equivalent fraction here. So I have to do 55 minus 24. Okay, 55 minus 24, you can plug that in your calculator if you find that you struggle with some of this, some of the math, just keeping it straight. Just plug in your calculator that process, 55 minus 24, which would be 31. Okay, and then over our denominator of 15. So now I have an improper fraction. More than likely, they will want you to turn this back into a mixed number. So 15 goes into 31 twice. That would be 30. So I would have 1 left over. 2 and 1, 15. Okay, so let's just try one example that is straight from our Smart Addition course, would be from one of your practice tests. Feel free to take a moment and try to solve this question, okay? Come up with your common denominator. First, you might want to turn them into improper fractions, as I suggested previously, and then see what you get. So I'll give you about a 20-second head start, and then I will start to solve. So again, I really like to turn into improper fractions when I'm adding or subtracting, so I'm going to do that first. Okay, so I get 7/6 plus 9/5. And now I have to choose the least common multiple or a good common denominator, which would be 6 times 5, which is 30. Now turning my fractions into equivalent fractions over 30. 6 times 5 is 30, so 7 times 5 is 35. 5 times 6 is 30, so 9 times 6 would be 54. Okay, adding the top, that would give me 89. 9, which again, you can totally use your calculator for 89 over 30. The last thing now is just, looks like all of my answers, notice, are in mixed numbers. Okay, so that's how they tend to ask the questions. They want you to turn it back into a mixed number regardless of how you solve it. So 30 goes into 89 twice. That would be 60. So that would leave 29 left over. 2 and 29 thirtieths would be my final answer. Cool. All right, so I promised you a couple word problems, so let's try it out. A baker uses 4/5 of a bag of chocolate chips to make cookies for the day. She does this for another 3 days in a row. On the 5th day, she only uses half a bag. How many bags did the baker use during these 5 days? So I'm just going to try to pull out some important information. Okay, so in one day, she uses 4/5 of a bag. She does this for another 3 days. Then on the 5th day, she only uses 1/2 of a bag. So how many did she use during these 5 days? So I'm noticing that there are 5 days here. So what happens in those 5 days? Well, day 1, 4/5 of a bag. And then she does it for another 3 days. So that would be day 2, 3, and 4. 2, 3, and 4. And then this is day 5. So notice how you actually have to multiply 4/5 times 4. That happens 4 times. A common mistake would maybe be just multiplying it by 3 because you see the number 3 here. So you really want to do some close reading to figure this out. So I'm going to do 4 times 4/5. That's how much she used in those first 4 days. And then I'm going to add the 1/2 that she used on the 5th day. Okay, so now my goal is just to simplify to solve. So we'll talk about this in a moment, but when we multiply fractions, we just multiply across the top and across the bottom. 4 is the same thing as 4 over 1. So this would be 4 times 4 is 16. 1 times 5 is 5 plus 1/2. And in order to add, remember we need a common denominator. Okay, so 5 times 2 is 10. So I'm just going to write my equivalent fractions, and I get 32/10 plus 5/10, which would give me 37/10. And notice again, all of my answers are mixed numbers. 10 goes into 37 3 times with 7 left over. 3 and 7/10 would be the amount of bags that she used during those 5 days. Okay, so just quick bonus review. How do I multiply and divide fractions? I'm going to go through this pretty quickly. It's pretty straightforward once you remember it. But in this case, we don't need common denominators. We just get to multiply across the top and across the bottom and solve. So 3/4 times 7/5. We just multiply 3 times 7, 21. 4 times 5 is 20. And then, of course, we've been practicing this a little bit. We just turn it back into a mixed number in order to simplify 1 and 1/20ths. Okay, 2/5 times 10/3. Something I do want to show you, though, that can be a little trick and can help when you are trying to solve questions like this. You could totally multiply across the top and the bottom the same way. 2 times 10 is 20. 5 times 3 is 15, and then simplify from there. I like to do what's called cross-canceling, and if I notice that some number on the top and the bottom share a factor, so 10 and 5, I can divide each of these by 5, I can actually simplify beforehand. So that's all the factors that are shared. So when I do 2 times 2 on top, I get 4. 1 times 3 on the bottom would be 3. This is the same thing as 1 and 1/3. Okay, so if you had just multiplied across the top and the bottom, you would get here as well, but you just have to do simplifying after you multiply. Cross multiplication is cool because you can simplify first. Okay, and just a quick reminder of how to divide. 3/7 divided by 5/6. So what we want to do here is think keep, change, flip. KCF, keep, change, flip. So what that means is I'm going to keep the first fraction, change division and multiplication, and then flip to be 6/5. Okay, so we talked about cross multiplication and cross canceling before. Don't be confused by that. One needs to be on the top and the bottom. Notice how 3 and 6 share a factor, but they're both on the top, so that doesn't help me. Okay, so I can't cancel anything out here. I'm just going to multiply across the top and across the bottom. Okay, and looks like there's nothing I can simplify. So 18/35 is my final answer. Cool. All right, so that's pretty much it for fractions. Just really want you to remember you need a common denominator in order to add and subtract, and then the quick little review of how to multiply and divide thrown in there for you. So when we're talking about decimals, I mentioned before that place value is super important. Place value basically just means that when we're looking at a number, each place that we can put a digit holds a separate value. So looking at this question, we'll just talk about, that place value in order to solve. So which decimal is the greatest? I see right here I have 7 hundredths, 7 thousandths, 7 tenths, and then this one is 7 10 thousandths. So when I say those numbers, I'm really talking about place value. So it's important to know your place value. So I'm just going to draw you a quick little picture here. So this is where my ones place is, for example. Okay, then I would have a decimal here. Then to the right of the decimal, we're talking about adding and subtracting decimals. We'd have tenths, hundredths, thousandths, and then you would just keep going, 10 thousandths, 100 thousandths. Okay, so these are all different place values. So when I look at the first one, 0.07, this is why I say 7 hundredths. 7 is in the hundredths place. Okay, 0.007, 0.7. So where the decimal is very important. Okay, and I can just make one more little place for this last one. Okay, so if I'm talking about which decimal is the greatest, basically what I want to do is look at the place values and see I have all zeros in the ones, but when I get to the tenths, notice how I have a 7 in the tenths. This is the largest place value where the digits differ. So this one would be the largest decimal, so 0.7. Okay. When I'm adding and subtracting, if I need to do it by hand, it's very important I put these decimals in the right place, or I'm going to be adding place values wrong. However, like I mentioned earlier, we can actually use our calculator to help with this, so hopefully this issue won't really come up. All right, so let's look at a few examples. 3.5 plus 2.04. So a common mistake that I've seen with students before is just to write, so 3.5 and then 2.04. Like if you are not careful to line up your decimal, you just maybe want the ends to line up because that looks nicer. Notice how you're adding 5 tenths with 4 hundredths. Just like with fractions, we couldn't add up things with different denominators or different units. We can't add these up because they don't all hold the same value. So it's really important that we line these up appropriately. So if I was going to stack these to solve, it would look like this. Okay, and I might just have to add in a little placeholder because now I'm adding the ones places, my decimals line up, I'm adding my tenths, I'm adding my hundredths. Okay, so this would give me 4, 5, 5, so 5.54. We totally can do this by hand if we want, but I would not suggest it because you have a 4-function calculator. Try to just plug it in your calculator and let the calculator figure out the place value for you. Okay, so why don't you try? Hopefully you have a calculator handy. If not, maybe you have something on your phone. Try to just plug in 12.2 plus 5 and let me know what you get. Okay, so just type in the chat what you get as your solution. 12.2 plus 5. Okay, so I get 17.2 as my solution. Okay, so hopefully you got that when you plugged in the calculator, and that is because when I stack these 12.2, the 5 is in the ones place. There is no decimal, but it's really just hidden here. You don't need it in this example. You could add your placeholder and get your solution there. Okay, and then last but not least, let's just do a subtraction problem again. Feel free to just plug it in your calculator, but I'll just show you why it's so important to stack these up. Okay, to subtract. And again, this would not really be ideal for having to subtract by hand because notice how I'm having to borrow and move things over, and that just gets complicated very quickly. And we just don't need to know that. That's not something we need to spend our mental energy on. So we could just plug it in our calculator to get our solution of 16.12. Okay. It's really just important if you have to either add or subtract decimals, or if we're just comparing decimals to see what is the greatest or the least, you just have to line up those decimals so you're comparing the same place values. Okay, let's talk about some ratios and proportions. So I have drawn a little picture here. I've got triangles and I've got circles. So let's figure out what is the ratio of triangles to circles. So ratios can be written in a few different ways. Okay, they can be written with a colon, A to B. They can be written as a fraction, A over B. They can be written as words, and this would literally just be A to B. Okay, so we can write them in all different ways. A lot of times with ratios, it's really helpful to write them as fractions, but I'll write them in each way just so you can see how they relate. So ratio of triangles to circles. So I see 3 triangles and 2 circles. So 3 to 2 would be our ratio of triangles to circles, or I could write this as a fraction 3 over 2. Okay, I mentioned earlier when we were talking about some of those common mistakes that order is super important. So let's talk about why. So for this one, this is triangles to circles. The next one, circles to triangles. Now I have 2 circles for every 3 triangles. This would be 2 to 3. And if I were to write this as a fraction, that would be 2 over 3. So notice how just flipping the fraction or changing the order of the way I wrote the ratio is actually a completely different ratio. Triangles to circles is not the same thing as circles to triangles. Okay, so that's why order is so important. And then what if we wanted to do triangles to total shapes? Well, there are 3 triangles, and how many total shapes are there? 3 plus 2 would be 5. So my ratio would be 3 to 5, or I could write this as 3 over 5. Okay, and just like a little bonus question here, something you might need to do. If the same ratio was maintained, how many circles would there be if there were 12 triangles? Okay, well, I could actually set up a proportion to solve this. So same ratios, how many circles would there be if there were 12 triangles? Well, circles to triangles I know is 2 to 3. Okay, so I'm putting circles on top and triangles on the bottom. This needs to maintain the same ratio. So this is going to be equal to how many circles, let's call it X, over 12 triangles. So I have circles on the top, triangles on the bottom. Okay, if I want to solve this, I could cross multiply. That's one way to solve this. 24 equals 3x. Divided by 3x would equal 8. So we'd have to have 8 triangles. You could also just try to figure out what would make this an equivalent fraction to solve as well. Okay, but that's how we may need to use ratios and proportions. As we prepare to do our last few practice questions, let me remind you one more time that studying for the TEAS test doesn't need to be hard or overwhelming. Eliminate the guesswork and stress of wondering if you're adequately prepared for the TEAS test. Get the online course that has everything you need to study to pass in an easy to understand and follow way. Check it out at www.smartadditionacademy.com. Okay, so let's try one of these questions right from our Smart Addition practice test. If a company's automobile fleet includes 132 cars of brand A and 48 cars of brand B, what is the fleet's ratio of brand B to brand A? So we need to do B to A, so order is super important. There are 48 cars in brand B and 132 in brand A. So this is my ratio. If I look at all of my options, it looks like we have to simplify. Notice how all these numbers are smaller. So you can do this in the same way as you would simplify a fraction. What factors do 48 and 132 share? So if I'm looking at my factors, I believe 12 would be a good one. 12 would go into both of these. So if I divide by 12, I'm going to get 4 to 11, which would be option number 1. And notice how, of course, that order is very important. 11 to 4 is not right. That would be the ratio of cars in brand A to brand B. So just really close reading is helpful here, making sure you put things in the right order. Okay, Hunter notices that she walked a total of 600 steps while walking around her work building on a 30-minute break. If she kept the same pace, how many steps could she walk if she took a 45-minute break? Okay, so this question we can solve using a proportion. So 600 steps in 30 minutes is basically the ratio that we know. So I'm just going to make sure we know. We have steps on the top and minutes on the bottom. So how many steps, we want this to be equal, could she walk in a 45-minute break? Well, I don't know the number of steps. I'm going to call it X. And then 45 is minutes. So steps over minutes again. And then here, I like to just do cross multiplication. It's nice and easy to solve regardless of the numbers. So 30 times X will equal 600 times 45, which is 27,000. When I divide by 30, okay, and you may have definitely got here another way, but I'm just showing you this process, kind of like a foolproof way to do it. You should get 900. Okay, the ratio of women to men in a certain industry is 5 to 4. How many people are in that industry? So the ratio of women to men is 5 to 4. How many people are in the industry? So asking a question like this, I just want to highlight this question because it's definitely a common mistake that people make. Ratios can change. So the ratio of 5 to 4, or not that they can change, but they can look different. So this is the same thing as 10 to 8, or 20 to 16, or 500 to 400. All of these are the same, and they all simplify to this ratio of 5 to 4. I do not know how many people are in this industry just by being given the ratio. Okay, the ratio is just saying for every, in this example, 5 women, there are 4 men, but we don't know how many there are. We just have that simplified ratio. For a question like this, if this is all the information they give you, there's not enough information to figure out how many people are in that industry. Okay, so just wanted to point that out, that sometimes questions like this, they try to trick you a little bit. You wouldn't be able to know how many people are in the industry just based off of what you were given. All right. Let's dive into some order of operations stuff. Okay, so order of operations, again, we talked about this a little bit before. This is straight from your Smart Addition lessons. Feel free to take a screenshot if this is something you struggle with, you want to have handy. PEMDAS, please excuse my dear Aunt Sally, stands for parentheses, exponents, and then multiplication and division. Notice how it's telling you got to go from left to right. And then addition and subtraction, again, from left to right. Okay, so when we are using order of operations, very important we do it in the right way. Okay, so what happens if I do it wrong? Okay, so I'm going to show you the right way to do it, and then I'm going to show you what happens if you do it wrong so you can avoid these mistakes. Okay, I like to write PEMDAS over here for myself so that I can just check it off as I go. So there's no parentheses, no exponents. Multiplication and division comes first. Remember, I go from left to right. So I see division first. I have to do 12 divided by 4, which is 3. And then I have 3 times 3, which is 9. Done with multiplication and division, and then I'm just doing addition and subtraction, which just leaves me with 9 plus 1, which is 10. So my solution, the correct solution, is 10. But what would happen if I did it wrong? Okay, a common mistake would be to think of PEMDAS and go, oh, multiplication comes before division, so let me do that first. So you would have 12 divided by 4 times 3, which is 12. Then you would do the division because that would come next. And you would just have 1 plus 1, which is 2. This is incorrect. However, I want you to notice how if you make this mistake, they put that as an answer for you. They're anticipating you making this mistake. Okay, that's why they're putting it as an option. You wouldn't even think twice if you made the mistake, but you get that answer. You see, oh, there we go. There's my answer. No problem. I want you to really be aware and internalize that when we have PEMDAS, multiplication and division, addition and subtraction, you have to work left to right. Okay, so here's another one. Okay, if I'm doing PEMDAS, in this example, there's no parentheses, there's no exponents, there's not even any multiplication and division, but there is addition and subtraction. So the appropriate way to do this would be just to work left to right. 3 plus 1 is 4. 4 minus 5 is -1. -1 plus 2 is 1. And lastly, 1 minus 6 would give me -5. That is the correct way to do it. If I were to do it wrong and think, oh, addition comes first always, the mistake would be to do the addition first and then this addition as well, 5 plus 2. Okay, and then you're only left with subtraction, and then you would think, oh, I would just do -3 minus 6, which is -9, which is incorrect. But of course, notice how they leave that as an answer option for you. So just really be aware, keep this in mind. Hopefully you took a screenshot of that. Here, let me go back to it real quick if you didn't already. Now maybe you see why it's so important. Take a screenshot of this so you remember multiplication and division, addition, subtraction, you always work from left to right. Cool. Okay, so let's just do a couple more examples of order of operations, and we'll just do them the right way. So feel free, if you're feeling confident with this, go ahead and give it a shot on your own. I'll give you a quick little, 10-second head start, and then I'm just going to start solving. Okay, so parentheses first. I see 5 times 6, which is 30. Okay, done with those parentheses. Now I see exponents, so I've got to simplify 3 squared. 3 squared just means 3 times 3, which is 9. Okay, now I'm moving on to multiplication and division. Left to right, I see division. 30 divided by 10 is 3. And then I see addition and subtraction. I see addition first, so I have 12 minus 2 would simplify to my solution of 10. Okay, so just working my way down and being careful to do it in the right order. Okay, try one more. Again, I'll give you a quick little head start, and then I will start to solve. Cool. Okay, so I am going to do parentheses first. I see 2 times 3, which is 6. Okay, and then multiplication and division is the next thing because there's no exponents. So I see 7 times 4 first, which is 28. 28 divided by 2 is 14. 14 plus 6, oops, sorry, my face is in the way, which give us an answer of 20. So hopefully you got 20, and there it is. Okay, so order of operations, PEMDAS, multiplication, division, addition, subtraction. Make sure you go left to right. That is the most common mistake that I see. All right, so let's talk a bit about exponents. We just mentioned it a little bit with PEMDAS, but let's talk a little bit more in depth. So 3 squared. Let's just first simplify some exponents. 3 squared just means 3 times 3. So the number times itself twice, okay? The exponent tells me how many times to multiply. So 3 times 3 is 9. This is not the same thing as 2 times 3, right? So an exponent is different than multiplication. We have to just make sure that when we're seeing exponents, we're thinking about multiplying the base times itself. So 5 to the third means the base of 5 is multiplied times itself 3 times. Okay, so 5 times 5 is 25. Times 5 again would give me 125. Okay, not the same thing as 5 times 3, right? Okay, now let's look. The most common mistake here that I see with exponents is not being aware of your negative. So let's talk about what happens when we have a negative. -2 to the 4th. So -2 to the 4th means -2 times -2 times -2 times -2. So just being careful, -2 times -2 is 4. Okay, 4 times -2 would be -8. -8 times -2 would give me a positive 16. So notice how -2 to the 4th power is a positive 16. This would be different than if it was just written as -2 to the 4th without those parentheses. What this means is essentially the negative is on the outside, and then you have 2 to the 4th, or 2 times 2 times 2 times 2. This would give me negative, and then this would all just simplify to 16. So this would be negative 16. So notice how these two questions are going to give you a different solution, okay? So watch out for those negatives. Okay. Here is a slide that I want you to just kind of follow along with me as I fill it in, but maybe, again, take a screenshot or take out your phone and take a picture of this. These exponent rules are going to come in really handy with some of the questions that we pull out from our practice test. So the first rule when we're talking about exponents is the power of 1. Anything to the first power is always that same thing. So here's our rule here. X to the first equals X. So what that looks like is if we had, for an example, 8 to the first power, that would just be equal to 8. So anything to the first power is just itself. Power of 0, okay, anything to the 0 power is always 1. So 4 to the 0 would just be 1. Okay, so anything to the 0 is always 1. Okay, so power of 1, power of 0. We also have the product rule and the quotient rule. So the product rule means if I'm multiplying exponents with the same base, I just get to add those exponents. So what that looks like here, 5 to the 3rd times 5 to the 6th would be 5 to the 3 plus 6, which is just 5 to the 9th. Okay. And similarly, but now when we divide, we just have to subtract those exponents. If you have exponents with the same base that you're dividing, you just subtract the exponents. So 7 to the 9th over 7 to the 5th will be 7 to the 9 minus 5, which would just simplify to 7 to the 4th power. Okay, and then just a couple more rules. We have power to a power, which means I'm taking some number with an exponent, raising it to another exponent. So the rule is here that you get to just multiply those exponents. So 2 to the 3rd raised to the 5th power, which would just be 2 to the 3 times 5, which is 2 to the 15th. Okay, and then negative exponents and fractional exponents. So a negative exponent, essentially the rule is just if you have a negative exponent, typically in math, we don't like that. We want to get rid of it and make it positive. So what we do is we get to just push it to the bottom, push it down and make it positive. So anything to a negative power, you can just put 1 over that number, and then you can turn the exponent positive. So for example, 6 to the negative 4th is the same thing as 1 over 6 to the positive 4th. Notice how 6 is not the thing that is negative. This is not negative 6 to the 4th. Those are very different. Okay, so you push it to the bottom and make the exponent positive. And then lastly, with fractional exponents, doesn't come up much, but just wanted to point it out in case it happens to pop up for you. If you have a fractional exponent, okay, so a fraction within your exponent, that's going to turn your number into a radical. So the top stays attached to your exponent or to your base, and the bottom becomes part of your radical. So what that would look like is if I have 9 to the 2/3, this would be 9 to the 2nd. The 2 would stay attached to the 9, all under the radical, and within the radical would be 3. So this is essentially the cube root of 9 squared. Okay, so those are just some rules. Here, let me just scroll up again, and I will just scroll down so you can take a picture as we go. So exponent rules here. Okay, so maybe just take a picture. I'll leave it up for a moment. I'll scroll down, and you could get a picture of the other rules as well. And then we're just going to do a few examples of questions that you may find on your Smart Addition practice test or throughout your lessons, which line up with what you may expect to see on your entrance exam. Okay, so let's look at those examples. 5 to the 6th times 5 to the negative 3rd. So this is the product rule. Sorry, this is the product rule. We are multiplying exponents that have the same base. So I just keep the base and add the exponents. 6 plus negative 3. 6 plus negative 3 is really just 3, so 5 to the third power, which we could actually simplify if we wanted to. 5 times 5 times 5 is just 125. Okay, let's see what happens when we do this next one. 2x squared raised to the fourth power. Well, what you want to do is make sure that this 4 is being applied to both of the terms within here. So this would basically be 2 to the fourth. And then we have x squared raised to the fourth. So let's see what happens here. 2 to the fourth can be simplified to 16. 2 times 2 times 2 times 2. And then x to the 2 raised to the fourth, you get to multiply those. 2 times 4 is 8. So this would be 16x to the 8th power. Okay, the next one again is another power rule, but we also have like a fraction going on here. So it's similar where you want to make sure the 3 is applied to both terms within here. So x to the negative second raised to the third, you would multiply negative 2 times 3, which is negative 6. Y to the second raised to the third would be 2 times 3, which is 6 as well. Now we want to get rid of that negative exponent on the x, so I get to push it to the bottom. So it's going to go next to the y to the 6th and make it positive. Okay, now let's look at a quotient rule problem. So now we are dividing. I like to look at these just variable by variable. So x squared divided by x to the negative third is really just x to the 2 minus negative 3. Okay, so it can be a little bit tricky, again, once you have those negatives in there, but 2 minus negative 3 is really just 2 plus 3, so this is just x to the 5th. And then I have y to the negative second minus 3, which would be y to the negative 5th. And then if I want to make that exponent positive, the x to the 5th can stay on top. We don't need to move that. But y to the negative 5th, we push that to the bottom to make it positive. Okay, and I have one more here for you. This one looks a little complicated, but it's going to simplify really nicely once we use our rules. So noticing how all of the bases are the same, we have negative 5 to the second times negative 5 to the negative second, all over negative 5 to the negative third. So what I would do first is I would take care of the multiplication up top. So the rule is you keep the base and add the exponents. 2 plus negative 2 would actually just be 0. So negative 5 to the 0, if you remember your 0 rule, that's really just 1. Negative 5 to the negative third. And if I want to make this positive, remember we were saying push it to the bottom? Well, it's already on the bottom, so basically what we can do is just then move it to the top. So this would just be negative 5 to the positive third. And if I wanted to simplify negative 5 to the positive third, okay, this would be negative 5 times negative 5 times negative 5 would give me negative 125 as my solution. All right, we've got about 10 minutes left. And the only other thing I really want to talk through is some geometry. And then we'll see if we have time to get through, some of these word problems that I have for you with geometry. So the main thing with geometry is that we need to memorize our formulas. Okay, so we're going to talk about some of the formulas we need to know, and hopefully you have some study strategies to help you memorize them. Okay, you need to know how to plug into those formulas. Once you have it memorized, then you need to know how to plug in the information appropriately and solve for, whatever is missing. You want to be comfortable dealing with fractions and decimals. You will definitely see that within your geometry questions, especially word problems. And then you also want to just know the difference between like area, perimeter, volume, surface area, like conceptually knowing the difference, because if a question asks you for something like the length of a fence around a yard, you need to know that that is asking you about perimeter, right? So like conceptually, you just need to know what each of those things mean. So here are some formulas that you need to memorize when it comes to geometry. Feel free to take out your phone and take a screenshot of this. We've got Pythagorean theorem up in the corner there. That is with right triangles. So this only works when we are talking about right triangles. It helps you find the lengths of the sides. I have some circle formulas here. Circumference equals pi times diameter. area equals pi r squared, and then the diameter is always equal to 2 times the radius. And then we've got volume and area formulas here. So let me scroll down a bit so you can see the next bit. Got some area and some volume formulas here. And then right at the bottom, just to wrap it up, I also have surface area, and then the area of a regular polygon is down there at the bottom. So these are formulas that you will want to have handy, find ways to study and memorize these, okay? So let's look at a few examples. A right triangular prism has a base area of 63 square inches and a height of 10 inches. What is the volume in cubic inches? So they're asking us about volume. Volume of a prism can be found by doing the area of the base times the height. Okay, so V equals the big B, okay, that's area of the base times the height. So they're telling us our base area, they're telling us our height. All I have to do is plug in for those variables. So instead of the area of the base, I can write 63. Instead of the height, I can write 10. Now the volume will just be whatever that is when I multiply, which is 630. Okay, so knowing that formula is the main thing here, and then can I plug into it? Okay, how about this one? A cube has a surface area of 54 square feet. What is the side length in feet? So for this one, the surface area formula may be helpful. But there's actually, another way to do it. Essentially with surface area, if you have a rectangular prism, you use that formula that was on the first slide here. A cube is a type of rectangular prism, so we could totally use it. The other thing that you could think about is essentially just like, what does this shape look like visually? Draw myself a quick little 3D picture. Okay, a cube is special because all the sides are the same. So all of the faces, we could find the area of all of these and they're all going to be the same. So surface area is essentially just the area of each of the faces combined. So if I needed to find the area of one of these faces, or I guess I'd use big B for that, right? Area of the base. I would just take the side length squared. Okay, so the surface area would be whatever that area of the base is. And how many of them are there? Well, there's 6 identical ones. So this is essentially a formula I can come up with just by looking at the picture. So surface area is 54, and I'm also just going to use side squared instead of base because that's what I'm trying to find. And now I can just solve for S. So once I plug into it, now I just have to know how to solve this formula. So 54 divided by 6 is 9. If 9 equals the side length squared, I just have to find what the square root of 9 is. So the square root of 9 would be whatever times itself gets you to 9, which would have to be 3. 3 times 3 is 9. So the side length would be 3. Okay, here is a circle question for us. The area of a circular hand mirror is 200 square centimeters. Find the circumference of the mirror to the nearest tenth of a centimeter and use 3.14 for pi. So for these questions, we typically need to know both formulas. So we are given the area of a circular hand mirror. So area equals pi times radius squared. We need to find the circumference. So circumference equals pi times diameter. So let's plug in what we know and try to solve and see how that can help us. So the area is 200. They're telling us to use 3.14 for pi. So first thing I have to do is solve for the radius. So I'm going to divide each side by 3.14. Plug that in my calculator, and I'm just going to round it a little bit. I get about 63.7 would be the radius squared. And if I take the square root of that, that's pretty close to 64. So my radius is about 8. Okay, so if I find my radius is 8, notice how in circumference formula I need diameter. So all I have to do is double it. The diameter is 16. So to find my circumference, I can just do 3.14 for pi, and 16 is my diameter. When I multiply those two, I'm going to get to the nearest tenth 50.2 as my solution. Cool. All right, and it looks like we've got about 4 or 5 minutes, so let me just talk through some tips for tackling word problems, and we'll see how many we can get through before we're out of time. So word problems are going to come up in every topic that we have. So we talked about a lot of different topics today and a lot of different mistakes that could come up. And word problems are just kind of like their own beast, right? Like we need to have strategies to tackle word problems so we don't make mistakes just by, misreading or misunderstanding what they're asking. So I practice close reading strategies. You may have noticed as I was going through a few of those previously, I like to circle, underline, write information out, draw pictures. These are really important strategies for tackling word problems. So doing close reading and drawing pictures can save you from a lot of the mistakes you might make if you're just trying to keep it all in your head. Okay, so if we can get some stuff down on paper, we can analyze some of these word problems a little bit more. You also want to just look out for some keywords, total, more than, less than, like things that allow you to figure out what operation they're asking you to use. Also, it's helpful to write out conversions and formulas that apply to that problem. So again, you're not just keeping it all in your head. If you know this question is asking you about area of a circle, write down the area of a circle formula so then you can just apply it. And then just a couple tips for especially multiple choice questions. Can you estimate to find the answer? Can we use friendlier numbers to help us choose the multiple choice option that is closest? Estimation can be really helpful. And then also, if you get stuck, can you use the multiple choice options just to help you get moving and help you get started? Okay, so let's look at an example. Okay, in a backyard, 1/6 of the yard is a garden, 2/5 is landscape, 1/3 is for play. How much of the yard is available for other use? So I'm noticing that there is 1/6, 2/5, and 1/3 all taken up. And then the question is asking how much is available for other use. So how much is left over, essentially, is how I'm reading this question. So if I add up what's being used, okay, then hopefully that'll help me find what's being left over. So now notice how I'm having to use my strategies for adding fractions in order to even solve this question. So this will definitely come back in word problems. So common denominator here would be 30. Okay, that's a multiple of all three. We had to do all three of these denominators, right? So 6 times 5 is 30. 1 times 5 is 5. 5 times 6 is 30. 2 times 6 is 12. 3 times 10 is 30. 1 times 10 is 10. So now when I add up the top, I'm going to get 27 over 30 is in use. Okay? So 27 over 30 is in use. But what is the question asking me? It's asking me how much is left over, how much is available for other uses. So we need to take the whole garden and subtract 27/30. So essentially we're taking 1 whole minus 27 over 30. But I can rewrite 1 as just 30 over 30. So if I do that, it's a little bit easier because now I have a common denominator. 30 minus 27 would just be 3. Oops. 3 over 30, sorry. Getting ahead of myself there. 3 over 30. So now notice how all of my answers looks like are simplified. So I'm just going to divide each of these by 3 and I will get 1 over 10. Okay, so 1/10 would be left for other uses. Okay, so I do have a couple more word problems here, but it looks like we are out of time. So I'm just going to go through them. Feel free to just take a screenshot. And if you want to try it later, give it a shot and then send us a message if you need some help solving them. But these are a couple questions that you may also come across on your Smart Addition lessons or within your practice tests. Okay, so screenshot a couple of these if you want a little extra practice with word problems and practice some of those strategies we talked about together today. Okay, again, word problems come up with pretty much every topic, so you need to be really comfortable with your different topics. Okay, so we are going to wrap it up today. I hope you found this video helpful and you have, some mistakes that now you will not make when you take your test because we talked about them together today. Otherwise, I look forward to seeing you in the next session and I hope you have a great day.